Okay, so in number 20, we have that lovely I again. This time, we can't have 0 as a denominator. We can't have negative numbers as a denominator. We can't have radicals as a denominator. And we can't have imaginary numbers either. This denominator is super finicky. So we want to do kind of like what we talked about with the radicals, where we wanted to rationalize the denominator. In this case, we don't want the I down here, and so we're going to multiply by something that would make this solvable. And we're going to do it by the conjugate, like we did when we had the radicals. So it's going to be the opposite sign. Same innards except for the opposite sign. And so what you do the bottom, you always have to do the top as well. And so we're going to do FOIL on both the top and the bottom now, so we can take these sets times each other. So the top one, we get 10, because first in each set, outer edges, inner, and then the last. And this makes that a -1, so it's really 3 times -1 there. So we have a -3 and a 10. So on top we have 7, and then the 2i and the 15i would be 17i. That's the top part. The bottom part, do you remember when you do FOIL but the sets look the same? With the signs being different, it's called the sum and difference of squares. So what happens is you can just do the F and do the L and you'll have your answer, but just in case you can't see that, the first, the outer, the inner, and the last. See how these middle ones, the O and the I, cancel each other out. That's why you can just do the F and the L. So now I have 25 and I have negative I squared, which is a -1. So it's a +1. So now we have 26 on the bottom because the 25 with the +1.